Hello all, welcome to the Clinical AI Academy, and today we have another journal club, the third journal club. So we already had two discussions published. The first one was about guidelines for artificial intelligence in medicine, and this last one was also discussing a paper, a current review of generative AI in medicine, core concepts, applications, and current limitations. Also, we launched the AI or like the clinical AI rounds, and this is the first video. So if you have not checked the previous videos, please go and check them. And today we are discussing another paper, a very interesting one. Let me show you. So today we're discussing a very recent paper published in the Korean Journal of Radiology, and it is another review paper or review article titled Real-World Monitoring of Artificial Intelligence in Radiology, Challenges and Best Practices. Before we start digging deeper into this paper, I would like to go back and show you some stuff that today is the 13th of October, and this is the third journal club. In Clinical AI Academy, we aim to improve AI literacy in healthcare by providing quality or high quality open source educational transdisciplinary content focused on artificial intelligence, neuroscience, medicine, psychology, linguistics, and more. We are choosing to go So we're focusing on using video format for communicating more than what I'm used to, which is written format, because I noticed that with video format you can pause, you can go back, rewind, rewatch, and honestly I'm a little bit I don't know about you, but fast content is a bit overwhelming, and I like to learn on my own pace, a kind of reflective learning. So that is the idea of to spark this, and also to build a community, or like I am learning and I am sharing my learning with you. So the idea is to build a community where like there's a video presence and shared presence, and that enables interaction through comments, discussions, and hopefully collaborative reflections and research at one point. So as I have shown you, we've released or launched the first video from Clinical AI Rounds, and the first video discusses what AI normal means. And we'll soon be releasing the ChatGPT and medical practice course on the channel. So those are the stuff I wanted to tell you about, and we can now discuss the interesting paper we have today, which is Real-World Monitoring of Artificial Intelligence in Radiology, Challenges and Practices. So okay. I used a notebook LM from Google to help me learn the paper, and this mind map gets generated automatically, so it gives like an impression of what's the paper all about. So the idea of the paper, to show that even if you have an AI that is working and that is published, an AI tool that is FDA approved or CE marked or whatever, in whatever country, whatever like regulation, that it is now approved for the market, so you can use it in your clinic. Even if you have one that is very accurate, very good, all the metrics are great, you need to monitor its output. And this is called post-market monitoring. So you have like, after it reaches the market, you need to make sure that it continually performs in a safe and as effective as it is described. So they mention in the paper the need for AI monitoring. So as said, ensuring safe use of AI. So this is by identifying clinical risks and model drift or data drift. So if you have a model that is trained on one data set, then you're using it for a different data set, then it does not generalize. Maybe you've heard of the word generalizability. So sometimes the models fail to generalize to new data, or even it could start performing well in your clinic with your own data, but then as time passes, there is like a model decay where, because of new data or new changes, like subtle changes in the input that you're having, or the clinical flow, or the codes you're using, or the documentation, for whatever reason, then you end up with a drift. So it's important to monitor that, and it's important also to make sure, ensuring safe use of AI, that you understand user behavioral trends. So even the human interaction as medical doctors with the AI, it's important to monitor it. This monitoring helps build, as they mentioned, helps in building user trust and acceptance. So because you are able to identify the pitfalls and challenges of this AI tool that you're using. So it's not only important to educate your staff on how to use it, but also when things go wrong, what can you do? So you build this trust also, as per the paper, by preparing comprehensive training packages, or by demonstrating good performance data. So this helps build the trust and acceptance of the users, and this is one of the needs or the purposes of AI monitoring. And then finally, optimizing AI effectiveness. So you are all the time monitoring what this AI is doing, and it allows you to, if you notice something is going wrong, that you intervene timely, and to keep the accuracy and efficiency as stated or as you wanted. And you help you like adjust the performance, so the sensitivity thresholds based on your needs. So you don't want sometimes it's giving you, it's very sensitive, that it's identifying a lot of false positives. So this overwhelms your capacities. So it all depends on, so you need the ability to monitor what's going on and to fix accordingly. And then removing certain functionalities. If you notice that you don't need those AI tools, for example, you have 20 AI tools, and then you don't need, like, some of them are not really, you're not using. So if you don't have monitoring capacity, you will not be able to identify those, and you will not be able to get rid of them. So you're wasting your time, you're wasting your resources. So then the paper goes into discussing the aspects that relates to the AI monitoring. So there is the technical monitoring, there is the algorithmic monitoring, and then there is the human AI interaction monitoring. So those the three things that they identified in the paper that you need to take into account when you're monitoring your AI. So for the technical monitoring, I think they have a nice graph that we can show, which is this figure. Figure number 1 is an overview of technical monitoring considerations for AI in radiology. So you have 3 things, or they identify 3 things for the technical monitoring. You need to look into the data flow and yield monitoring. So they identify yield as the percentage of examinations generating valid AI results. So this is like, you want an AI that optimally gives you valid results, right? And if you have like an AI is giving you 50, or it used to start with like 80% valid AI results that you could trust, and now it's giving you 50, then you have an issue and you really need to monitor that. So from the data flow, you need to monitor from image acquisition at the modality to the AI analytics server, and from the AI analytics server to the PACS and reporting environment. So those are two fields that you need to look into to ensure a proper data flow. The second point in technical monitoring is monitoring traffic and timely delivery. So you don't want your AI to be delayed when you really need fast output. For example, think of the brain. Think CT scans of the brain, and you know that where's the mantra in neurology? Time is brain. So if you're delaying, then you're losing the output of the patient, so the health outcome will be affected. So you really need to monitor the network performance. You don't have delays, you don't have glitches, and also monitor the AI analytics server capacity and resources utilization. So to do that, they suggest logs, timestamps, and statuses. The third point they suggest when doing the overview or the technical monitoring is orchestration of relevant examinations. So if you have multiple AI tools and you're trying to, so you have let's say an emergency, and you're trying to triage your cases to the different AI tools, and imagine like you have you send like pediatric bone scan or like CT scan of the bone for pediatric, or for pediatric to trauma AI tool, or for adults, then it's not gonna work, right? So it's important that you are able to monitor the orchestration of sending of those information to the different AI tools, and to identify the tools that are not suitable. And this is done by keyword mapping. So you have 5 keywords, let's say, and then based on them you use the different AI tools. But if you have 20 AI tools or more, then this gets very difficult. Especially if you're, for example, teleradiology situation, that's what they mention. How would you triage? Like you send you would be sending the false exams to the false AI tools, so it's not worth your effort. And then manual forwarding might be like you have complete control, but the issue is you need people doing that, and this is time consuming, so you will have time delays. And then the final, which is the cutting edge, AI assisted orchestration. So you can analyze multiple data sources, but the disadvantage is you need in-house technical capacities, and requires technical capabilities and in-house development, and this might not be available in your average clinic. So that might be an obstacle to do or perform the monitoring requested. Right, so this is an overview of technical monitoring consideration for AI in radiology. So the other aspect that they mention that we need to monitor is algorithmic monitoring. And this is done by continuously evaluating your key parametric, factors, compare output with ground truth. That's what this is always the ground truth, which is if you have an AI, the data set is determined by what the human radiologist suggest for the scan. Is it normal or abnormal? That's what you compare your output, and then characterize type of errors like misinterpretation, limitation, so proper documentation. And this is always, keep in mind, continuous real time. That's where this review excels at is that it's trying to identify the real time monitoring. And then independent benchmarking by using local data sets, workflows, check vendor claims, uncover performance gaps by uncovering like bias, basically underserved populations that are not represented in the benchmark for the AI tool that it was developed using. Then analyze performance by cohorts. So if you have different scanners, different size, different patients cohorts for monitoring, you need to take that into consideration and detect unintended biases. Then performance thresholds and alerts. You need to also be able to set statistical control limits, and then escalate to clinical governance committee. For example, if you have decay in the performance, so you need to be able to monitor that and then act accordingly. Then the issue with the ground truth thing, like, is you're asking the radiologist to do that. So you're asking the radiologist to label each exam that is being tested as a good or bad, for example, good quality or bad quality. And this is time consuming. And not realistic, and puts more burden on an already burnt out situation and burnt out workforce, the radiologists. So they mention that you have different tools or systems to do that. For example, from the AI vendor themselves. So you don't put a lot of technical effort, but then you're waiting for them for the vendor to give you feedback, and sometimes it's fragmented. Maybe you hire third party. You have them focused, so centralized oversight, monitors multiple systems, but then also adds on the costs. That's a disadvantage. And then you have extensive system integration. So you need to fix the integration thing, while if it's from the vendor, then it's already integrated and you don't have to go through that again. Third ability or third possibility for you to extract the ground truth is to build an in-house monitoring system. This allows you full control and adherence to internal policies, privacy, ethical protocols. So you're according to your own institute. The issue is you need internal resources and expertise for that, and it's not always available. So finally, they suggest the use of large language models. So large language models are able to take unstructured data and find patterns and give an assessment. So you have an automated alignment assessment, and I think what they did is they ran an experiment using that, if I remember correctly. And for the in-house monitoring, right, and then let me check. I think it's somewhere here, right? Right. In retrospective internal evaluation in 2024, so 1,000 reports were reviewed by 4 radiologists, and to establish the ground truth by comparing radiologist reports with AI output for pulmonary embolism detection. So then they have key performance metrics were then derived from 2 monitoring approaches: the radiologist input via agree with AI button, and GPT 3.5 Turbo, a proprietary large language model that automatically analyzes alignment between AI output and radiology report. So the large language model demonstrated closer agreement with the ground truth, right? So it was able to assess the reports and say, okay, it agrees, it doesn't agree, and it was very close to the ground truth even closer than the manual feedback, because radiologists does not have enough time to go into the subtle details and figure out what's going on. Like sometimes they're just want to get rid of that situation, move on, or they're choosing, so they identify like biases in the human evaluation, for example complacency bias or cherry picking behavior, among like the biases that reduces the ability of the human evaluator to say, okay, good output or bad output. So yes, that's for the use of large language model to identify the ground truth. And human AI interaction monitoring, I think we kind of touched on that already. So from the cognitive biases that stops like us from relying, or we want to move away from the human monitoring to a more AI based monitoring, as we have seen with the internal testing that they have conducted. Right. Okay, so let's go through the figures that they have and see. So that was an overview, and now we can chill and spend more time on the figures. So figure 2 is they're showing the AI monitoring workflow from capturing the image, sending it to the PACS, and then the gateway, which determines, okay, accepted, and then to the cloud, and then gets like processed by the AI system, gets accepted or rejected, and tells you why. So that is the AI monitoring workflow end to end, from image acquisition to feedback loop, followed by the image transmission and gateway. From the gateway, data are sent to the cloud. I'm interested to know what they meant by gateway. So right, it's not defined, so apparently it's to the vendor AI gateway. Yeah, right, it's not defined. Maybe it is, but I cannot find it. All right. Yes, I mean, it's just like an overview of how, and then there is time that is being calculated and always recorded, to be able to do some audits later on. So the AI results are either accepted and returned to the clinical environment, as you can see here, or rejected due to missing data or processing failure. But then in one graph, they show that even sometimes you need monitoring of this step here, because sometimes things go wrong in this step, and then it is labeled in a wrong way, as we can see from this graph, which was a little bit confusing for me to look at. Okay, what's happening here in this figure 4? Why is it not mentioned already in the first figure? But it's okay. So yeah, sometimes the AI fails, not because it's not able to process things properly, but because things are not transferred properly. So maybe you have one slice that is not sent, and then optimally it will be able to detect that, but sometimes it does not detect it and then gets sent back as normal, and you don't want that. So right, that's the figure 2. And then we have figure number 3, where they show, and I think that's their data from the telemedicine clinic, and very interesting stuff. So I think they scanned so they have developed a dashboard that monitors things on the go, and this is really nice. So they have this retrospectively looked at around 24,000 studies, and they ask, I think, all the time their radiologists to say, okay, AI was helpful, AI was not helpful. And 90% of the time, the radiologists found that the AI was helpful. This is great. And you can look at the dashboard, you can look at the surface type, section, exam type, and reader, and then monitor everything. So here, something was found, something was not found, and so if you're monitoring or if you're looking at your AI, if it's performing well, it's nice to have such a dashboard, and now it could possibly be easy to develop that even in-house with vibe coding. Right. So, and then I think that they are right now trying to implement that in the Southwest London National Health Service AI working group, and they have demonstrated practical benefits of structured AI governance. Right. So that was what I wanted to share with you today in regard of this paper. I really hope that you found this helpful. Key message: it's important to monitor your AI on the go and identify issues as soon as possible, and hopefully be able to pinpoint why this is happening and then fix it before it ruins your workflow. It ruins all your clinical workflow. Either overwhelms you or end up under-diagnosing your patients, and this, as you can imagine, is not something good to have. So that is the paper for today. I know, in our update, we were going to discuss a different paper, but I noticed that I was not sure from the resource. It did not sound like it is without any conflict of interest with anyone. So I decided to go to a more objective, or a more objective paper, which is this one, and very insightful. Thanks for the publishers, or thanks for the authors for taking the time to share their thoughts and their work with us. The next paper will be the illusion of readiness, and stress testing large frontier models on multimodal medical benchmarks. And as we're finishing, I would like to invite you to provide your feedback, contribute, share the discussions, tell me your comments, your answers, your questions and answers, and happy to try and answer your questions. This will help me also learn and hopefully help us build a better community around this topic. Join the newsletter on Substack to receive the latest updates, recordings, and events. Join us on YouTube, and always suggest topics, papers, and resources. Thank you so much for joining me today.